That morning meditation exercise was great. By our choice, we soared. Most of us hopefully have come down. And those of you who are with the Indian mythology know that there is something called the Trishanku Swarga. You are neither not there, you are not here or up there. You are somewhere in the middle. If you are in the middle, see me later. Okay. We have been talking about a set of phrases. Smarter planet, many of you understand that. Smarter computing, new era of computing. What I'm going to try to do is to put in perspective. Once again, we wanted perspective, opportunities. What is the IBM portfolio that is needed, or anybody else's portfolio that is needed, in order to realize the opportunities by addressing the challenges. And by the way, what are some of the important trends in the industry that help going in this direction? And that's a technology statement. Now, what's in it for you? Couple of points. These have been made. I want to reiterate it. One, on the beginning evening, Esther pointed out, using the CEO study, that technology is being viewed as a potential game changer. And the second is we have, as you are going to see, a lot of the capabilities to do that, but as the world shifts more and more into value-driven rather than cost optimization, it is important to team up, because this is not something that can be solved by one vendor, one company. So you as business partners, you as systems integrators, in providing a solution that help provide the client value, which is the same point that Joseph made, right? It is very important. Now, as we go through this discussion, I'm going to have a special reason why we want to do this, and that is in providing the technology capability to get you better understand, to get you a higher degree of comfort, to provide a level of training, to provide a level of education, participate with you in the proof of concepts, including being able to help you understand where we are going in your consulting practices or service providing or the managed service practices. In these things, there is a lot of value that we bring in the systems group as well as the software group, because in India, we have a significant lab presence in here. And I just want to take a moment to introduce some of the talent that we have here. If I can ask the people in the systems group that are in this, that we can help collaborate with you. We have Rajesh, who is the technology and the hardware development in India, and Monica Agarwal, system software and system firmware, and Anuj Garg, who leads storage development out of India, and Naveen Kamath, who collaborates with clients for better acceptance of our technology using the lab-based services. So my point is, going back to the theme that Esther also pointed out, collaboration. Now we have a more intense way of collaborating with you, and I would like to take those opportunities. So with that in mind, can you roll the video, please?
I used to think my job was all about arrests, chasing bad guys. Now I see my work differently. We analyze crime data, spot patterns, and figure out where to send patrols. It's helped some U.S. cities cut serious crime by up to 30%. By stopping it before it happens. Let's build a smarter planet.
That's a cute video, but it is more than a cute video. IBM has a program with the city of Memphis called a Blue Crush program, where using data patterns, serious crime was prevented to the extent of about 30%. And the point of that video and the point of this chart is, as many of you know, you are a computer services company participant, and for a large extent, it has been cost focused. This is something that Esther made a point yesterday. But as we realize, I'm also realizing that more of you are realizing that it is more and more about creating client value, business innovation, and enabling it. The opportunities that we saw, like the Blue Crush program and a few others that I'm going to talk about, are redefining how industries are working and how businesses are working. Example on fraud prevention. The state of New York uses data to prevent improper refunds to the extent of $2 billion and accelerate the collection of delinquent taxes to the extent of $150 million. Many of you have seen some of the examples of the smaller cities. City of Stockholm. City of Stockholm, using a combination of sensors, weather prediction, traffic congestion prediction, is able to implement a variable electronic toll system where if your vehicle is driven on the most congested routes at the most congesting times, most polluting times, you pay a much higher toll, which is automatically enforced on you. Reduced traffic congestion by 18%, increased public ridership by 60,000 people. In the area of banking, where smaller and medium banks are at a disadvantage compared to larger banks who have the ability to gather a lot of data so that they could be better serving their clients, those advantages now can be provided because there is a company that provides this kind of data for smaller and medium banks so that they could compete with the bigger banks. So data and the ability to create value is redefining industries. However, I will also take a moment to put some of the challenges that are created by this. There is an estimated 2.5 exabytes of data that is being created on a daily basis, along with a very large number of mobile devices that are connected to it. And to put that in perspective, the entire information that has been created since the beginning of civilization till 2003 is estimated to be 5 exabytes. So what we are creating, at the same time there is a value, there is a huge challenge. Joseph already talked about this, so I won't necessarily go much into it other than couple of important attributes. The 4 V's, most of the industry talks about the 3 V's, we actually need to understand the data endowed, how to get value out of it. But the storage that is required, the amount of the data that is required, requires a different way of dealing with both the costs as well as the management capability. Towards the end, I'm going to get to what we mean by that in terms of the smarter storage. So while there are these kinds of opportunities being realized, there is a very clear challenge to the IT leaders. Transactions, billions of transactions. The fact that service delivery today is very siloed between the business process, the systems that realize it, the data that provides it, and the connectivity and the applications. In fact, in an earlier study that we did of the worldwide data centers, only 20% of the data centers, 1 in 5, was able to put more than half of their IT budget for creating new business value, the new client capability, or the new application environments. So by that definition, 80% of the data centers are inefficient. And costs. Another study, Forrester's in this case, essentially 23% of the IT projects, and I think Amit referred to some of it yesterday using the Mayo Clinic, 23% of these are both over budget as well as late. So there is a set of issues that need to be solved, and there are also opportunities, future opportunities. If you can roll the second video, please.
Rio de Janeiro, well known for its rich culture, active lifestyles, and stunning natural beauty, is also burdened with crime, aging infrastructure, and natural disasters. A burgeoning city of 6 million, Rio now prepares for millions more as they get ready to host the 2014 World Cup and the 2016 Olympics. Like other forward-thinking cities, Rio realized it was in need of a new city operations plan to improve emergency response coordination, manage increased traffic, and improve services for citizens. Rio turned to IBM to create a smarter city by integrating more than 30 agencies into one centralized command center. The new Smarter City system gathers data from sectors across city operations, making it easy for security officials and crisis managers to monitor and respond to problems quickly. Data from sensors and video feeds create real-time maps and graphs, working to predict problems and counteract them. The result is a visionary city, equipped to react, predict, and plan for current and future events.
So, there is future opportunity, value has been demonstrated, industries are being redefined, but there are huge challenges. So what do we do? Smarter computing is IBM's point of view on what is needed in order to solve this. This is not so much an architecture, but it is a disciplined way of thinking about how IT infrastructure of the future needs to be built with a degree of discipline, with a degree of understanding, with a degree of forward thinking. And that's what we call smarter computing, is the IT infrastructure needed to realize the benefits of a smarter planet. And there are three components. One is design for data. The ability to use all the data, not just the structured data, the unstructured data that Joseph talked about, along with the new kinds of data, streaming data, also factoring into account how decisions can be made on the basis of data in doubt. And by the way, this is not just IBM's point of view. CEOs want to do this as well. The other is breaking the silos, which is to improve the ability to do IT service delivery with a much higher degree of flexibility at a lower cost, improving the elasticity, and being able to provide quick response time. Once again, most of the CIOs want to do this. Instead of calling it cloud, we call it managed with cloud technologies, because a lot of it has to do with the IT infrastructure part, has to do with virtualization management, and being able to apply virtualization not in a restricted context, but widening the scope of it. If we did only those two, we would still not solve the problems, because IT budgets worldwide are flat, are declining. And yet, what we saw, the data tsunami and the technologies coming at us, including the mobile, that forces a different challenge. And what we think that is needed in order to do this is the concept of optimized systems. Optimized systems, which is what I'm going to talk a lot more about, is about understanding workloads in the context of a business process and matching systems that implement that. And the system in this case is not, in this context, is not a server. It is the total system, including the application environment, the middleware, as well as the hardware, software, including network and storage. By doing this right, it is possible to reduce the cost. So the purpose here, once again, is not to reduce the cost, but save enough in one place so that you can pay for the innovation in other places. Joseph already talked about, so let me quickly talk through each of these things. You have already seen when Joseph talked about what is involved in creating the big data platform. Dealing with structured data, unstructured data, Hadoop-based, streaming data, info streams and others, but being able to integrate all of these, structured as well as unstructured, linear as well as insight creation, and being able to provide that in a single context. That's what this is about. And that involves more than just the analytics. It requires understanding of the data sources, what data you have, what data is external, being able to provide the right lifecycle management of the data, being able to choose the right analytics environment, and providing the various governance metrics, including the protection of the data that various regulations require. And underneath that, it requires understanding what the storage needs are that data drives. Now, tune to the task essentially says you need to understand the workloads and match the workloads with the systems that are best able to execute it. By the definition of IDC, there are three broad categories of workloads. One is transaction processing and database processing. The second one is analytics. And the third one is business process management. Let me just quickly go over how these workloads are very different in characteristics. In transaction and database processing, there are thousands, hundreds, or perhaps millions of users, online users. Response time latency is extremely important. It is not computationally intensive. It is I/O intensive. You bring in a few records at a time, but on behalf of millions of transactions at the same time. And by the way, locking and those characteristics are very important because the data that is created by one transaction may be used by another transaction. And the efficiency with which those things are managed is critically important. But even more importantly, it is about data. Transactions produce data, and data is essentially what an enterprise like a bank is. And therefore, being able to secure the data, being able to protect the data, disaster recovery, as well as being able to access the data from multiple sources. These are not done in a piece of hardware. It is really a stack level optimization. That's one of the points that this chart makes. The other, if you look at the characteristics for analytics, analytics is very different compared to transaction processing and database processing. There are a much smaller number of users, typically business analysts, and as CEOs and other business leaders become more of the analysts, this is likely to become even smaller. This is computationally intensive because you throw things like Monte Carlo methods or other data mining methods. It is not latency time responsive. On the other hand, it is data intensive, but not necessarily I/O intensive. We are bringing in lots and lots of data at a time. At least at this point in time, it does not have the same security characteristics. It does not have the same disaster recovery characteristics, the same requirements for accessing the data from multiple systems. Compare this to business process management. Business process management workloads are neither computationally intensive nor I/O intensive. They do demand flexibility. They do demand ability to be done on a very large variety of platforms, especially Java-based or other portable environments. So our point is multiples. One, if you pick one as the answer, then the resources that are implemented in the system, total system stack, they are going to be suboptimal or not being used, and therefore will lead to inefficiency, whether it be in floor space or power, energy needs, responsiveness, etc. In that context, the metaphor is like the game of golf. In golf, you could pick one club and use it throughout your game. But you don't do that. You use a whole bag of it. The reason is it is not about hitting the ball. It is about getting from point A to point B with the least cost. And that's the reason why you have wood, iron, titanium heads for various conditions. So understanding the workloads is critical. Second, the workload optimization is not optional. It is because the way the nature of the technology is going, the growth in thread performance is not going to be coming for anybody's, not just ours, but any semiconductor technology vendors. More and more of the capabilities have to be built into the compilers, into enabling that through the operating systems and the firmware, and using in the databases. Example, power. As thread performance is not growing at the same rate, the capacity to do more work is being done through multi-core and multi-threaded designs, where power is a leader. However, to give the value to this, one has to take advantages in the Java compiler. It has to be enabled in the AIX operating system, and the capabilities like using different keys to provide security, they have to be used in middleware like Db2. So it is more and more about building the stack, the vertical stack, and the way it is optimized. It is essential for the future. I think Amit mentioned a little bit of this. There are different models that clients use. On the left-hand side of your metric, it is the generally known model where things that are optimized, systems that are optimized for transaction processing, which is typically what the mainframe does, analytics, which is typically what our systems do, and business process management, which is most of the x86 platforms, but with a better I/O that we provide. These are acquired by clients, and with the help of services that we provide, clients have, or you provide, people put them onto a broad variety of workloads. However, it takes skills, it takes time. That's the known world of today. At the other world, at the far right end, is the appliance model. In the appliance model, it's possible to put to work, whether it be for data warehousing using Netezza, or web services security and XML efficiency using data power. Appliances that do not require much skills but can be deployed very fast. However, they have a restricted set of workloads that they do. In between is the ability of today's integrated optimized solutions. An example of that is what we have done with the smart analytics system, where we have taken power, some of the middleware components that are needed for providing warehousing capability, and built-in storage, and provide a level of flexibility to do that. And that sits in between in terms of the workload flexibility, skills needs, and the ability to deploy. In the future, as I think Amit pointed out, or I think Joseph also mentioned that, the capability to serve this space with a higher degree of flexibility and greater workload optimization is going to be built on the Pure Systems platform. Based on my discussion on the workload characteristics, you would accept that there are significant cost characteristics with the mainframe platform, especially with the hybrid architecture. One can create a mixed workload environment using a combination of AIX x86 or Power AIX x86 and the traditional mainframe workloads, integrate them, manage them with a higher level of efficiency and reduce the cost. In the power systems, because we have been a leader in providing processor designs and therefore for a given amount of capacity compared to other Unix vendors, you require a smaller number of cores in order to achieve the same capacity. You can reduce the license costs, and at the same time, at the higher end of the systems, you can achieve a higher level of security and a higher level of availability with power-based systems. System X, we have redefined. The x86 part of the world grew up from the habit or the practice of taking what was on a client, a motherboard with a certain amount of I/O capability, certain hard drives, certain number of processors and connectivity, and turn that on its head and say this is a server-based design. Just basically put more of it. However, as workloads demand disproportionate amounts of memory, and as virtualization changes the game, it is necessary to redefine that. And that essentially is what the flex systems discussion that Amit was taking us through yesterday. Storage, I'm going to talk about that in a second. Amit also talked about why Pure Systems bring in a lot of benefits, but let me also put that in perspective a little bit. There is a growth opportunity, but the client-tuned systems, the ones that we talked about as the high-end power systems and the mainframe systems, and even the flex systems using x86 component, that is not going away. The piece parts business will continue, and your participation and partnership in that, making that a success is essential. And IBM is investing a lot of capabilities and money into creating the future of these things. Some of the examples that are given here, right? The mainframe will continue to have thread performance as its goal, will do operational analytics within its own premises to improve availability. It will take advantage of solid-state disks and provide significant improvement in lapse time for important workloads, and will continue to invest in providing the enhancement, both the hardware as well as the software. So there is a roadmap for that. Power will continue to improve its cloud capability, its security, availability characteristics, and the ability to do broader set of workloads through workload optimization. In System X, we already talked about the flex system, so I won't go through necessarily a lot more of it. So let me shift my attention to where the future is going. Ever since one Neumann computers were built several years ago, this is the world that we have known. We started making processors faster and started putting more capacity. That became scale-up systems. Then we started scaling them out once workloads became different and they could be served by having multiple instances of the same image, doing a lot more collaborative work. However, both of these have certain limitations, and the technology trends are such that it's possible to create a new model. Just very briefly, as the density of processors, as the density of semiconductors continue to build within a small number of sockets, very large images. You can build a 96-way within essentially in the very near future within a 4-socket system, because in the next year or so, we're going to have 16 cores per socket in the industry. So, density. The other is I/O, the components of what a system is. In order to build a balanced system, I/O is needed. And one of the aspects of this is the storage drives. As the capacity of a storage drive keeps growing, but not the performance in the I/O operations per second of the storage drive, they are not growing at the same rate, because in today's hard drives, it is built on the rotational speed of the hard drive, which is not going to keep on increasing beyond 7,000, 10,000, 15,000. In my life, I'm not going to see 50,000 RPM drives, nor would you want to. Alternative technologies like solid-state disks and storage class memories, these are emerging. However, these are also going to be capable of being built into a server integrated storage, and these are going to be expensive, and therefore the archival and other lesser performant but lower cost devices, they're not going to go away. So this will redefine the storage hierarchy. In the definition, in this redefined storage hierarchy, being able to place the data in the right place, the right tier, and getting the right balance between performance and cost is going to be very critical, and it cannot be done manually. And it is going to be done in an automated fashion. That is the concept of easy tiering. And the third one, perhaps one of the more important ones, is as scale-out systems continue to grow, the interconnect between the physical systems as well as the virtualized systems, the virtual machines, is making a significant change. First, I'm going to talk about the physical systems. The physical systems, instead of a processor memory bus, as the system networking, fiber channel over Ethernet, Ethernet capability, as it grows at an enormous rate, and as technologies like remote DMA, standards-based ones, as they provide a low latency interconnect between different dissimilar systems, even though they are not shared memory, this allows you to create a very different kind of what a system is. So one can rethink what a system is, different from the one Neumann way of doing it, and then build with a much higher level of capability. That's what we have done with the flex systems or the pure flex systems. Now you add to that another very important metric. As virtualization becomes more and more pervasive, there is a need for either federating or increasing the scope of virtualization beyond just a server. Server, storage, and networking, they all need to be taken together and virtualized together, managed together, provisioned together, and not just in a dynamic way, but with programmatic interfaces. Because when you want to get to cloud, infrastructure as a service or a platform as a service, it is not a human being that is provisioning those things. Those are images that are put together, they are dynamically provisioned. In that kind of a world, it is necessary to go into this scaling model, which is what we have built with the flex systems. And Amit already talked about some of these things, so I won't necessarily take the time to do that. But I will emphasize that since we talk about cloud as one of the important values that we create, it is possible to take the smart cloud entry that is embedded into the PureFlex systems and get to a private cloud enablement very fast, essentially with 4 clicks. And that is enabled because you have a completely integrated storage, networking, and server environment with a choice. And by the way, the fact that there is a choice of the virtualization capabilities, you can have either a VMware or a KVM or a Power VM or a Hyper-V. This allows customers to stay with what choices they have made from a virtualization environment capability. Now, we talked about patterns yesterday, and I want to bring in a different aspect of the pattern because I'm going to make a connection at the end of my discussion on where this is going. Patterns is a very simple way of, in the traditional way of looking at this is, the business essentially says, I want to do this application. And by the way, this application needs to scale. Now, when the IT folks get involved and start parsing that, what you discover is that it is not one thing, it is not an application. There is a bunch of components in there. There is an application environment that may be scaled, multiple instances of the application. There is a caching server or a caching capability. There is a database and a database schema. There is a security, LDAP. And these need to be connected together in some topological fashion. Along with the other parameters that Amit talked about, this topology is something that one does not need to invent and reinvent every single time. For 80% of the applications, these are predefinable, and that is essentially what the patterns are about. But I want to put a point in here that will connect up at the end. Most of these are going to be virtualized. So the instances of the applications that we are talking about, they run in a virtual machine. Databases, instances, they could also be running in a different virtual machine. The caching servers, multiples of them, they will be running their own virtual machines. What is the interconnect between them? It is the network. In the world that we were in, these were physical network connections. But in the world that we are already in and moving forward, these virtual machines are now part of a server environment. And we are expecting hypervisors, a piece of software that manages a server virtualization, to deal with these. And in order to get into the future of the programmatic-based way of providing network services in the future, or cloud services in the future, we need to address this convergence between what a physical network was doing and what a server-based virtual machine interconnected network needs to do, and patterns provide a very important role in the future. And by the way, the point that I want to re-emphasize is patterns are not provided just by IBM. Business partners can provide it, our customers can provide it, and there is a set of tools, as Amit demonstrated, that will help do that. Let me talk briefly about storage. There is a lot of focus on storage growth because the capacity for storage is growing at a much faster rate than even the server capacity. And there is a cost associated with managing that. But I also want to take a more complete look at storage workloads. You can talk about storage workloads as two different things. One is the production data and archival data. In the production data, what is critically important is what I mentioned earlier, the focus on the data. If data has to be secured using encryption, removable media encryption, one needs to be able to do that, including the key lifecycle management, which typically is not a hardware job. It is typically a middleware job like Tivoli. The other is for very high levels of availability, IBM as well as industry vendors provide copy services. Important, good, but not enough. Because data, being able to provide the data and the synchronicity of data across multiple sites is a software managed thing. Therefore, there is high availability software, either as part of the operating system or in the case of the mainframe at a higher level stack, including the GDPS offering. They become important. So the point I'm making is to provide adequate, useful value in a storage environment, you need a stack. And the stack is not exactly the same stack, but you need a stack. And the stack includes operating systems, middleware, as well as the storage hardware and the storage firmware. In the area of archive and retention, there are a lot of regulatory issues. This is where the storage hierarchy change becomes important, and focusing on the cost is important. And there are a number of things that we will talk about in the context of smarter storage. And that's the next topic. So what we said in smarter computing was to realize the benefits of the smarter planet, you need to focus on the data and how all the data is taken advantage of. You need to provide virtualization and other technologies for managing the IT service delivery, and then we need to provide optimization or tuned to the task to make it cost effective. There is a corresponding need for the storage systems to fit into this, and that is what the concept of smarter storage is. It is necessary to, in the context of the design for data, it is necessary to provide efficiency of the design, efficient by design, and in the context of manage with the virtualization technologies or manage with the cloud technologies, there is a need for providing cloud agile is what we call it. It is providing the virtualization for the storage environment, and storage systems need to be able to take advantage of the workload characteristics that I mentioned and provide optimization, both for cost and others. This is an eye chart, but you don't necessarily need to read this. There is one of the poster sessions, one of in the Solutions Cafe is what we do in terms of storage, smarter storage, and where we are going with this, and what are some of the capabilities that are emerging, like the real-time compression that we have introduced in the V7000, like the smart tiering, and how they fit into this. And also part of that is some of the capabilities that the India-based team develops, which is providing the improvement for efficiency for storage virtualization across a wide area network connect, which is the active cloud engine. So let me talk a little bit about how the networking and the networking of the future fits into this. So I started by saying when we start virtualizing and start using virtual machines, the connectivity between the virtual machines becomes a network. And as we have done in the case of the PureFlex systems, we have integrated storage virtualization, storage management, along with the server management and the server virtualization. If you look at the bigger picture that's happening in the networking functions typically are designed as a monolithic stack between how a physical part of the network, the control, the data, and the control and data planes, multiple switches, and the network operations, the network functions, the network management functions, like the layer 3 functions. How these are put together has been in a very rigid monolithic stack. And what the industry has realized is that as virtualization has started taking hold, there is a lot of complexity and cost associated with the current networking design. So let's take a couple of instances. Because the density of processors keeps on increasing, there is going to be more and more so-called cores per socket. There is going to be a 10x increase in the cores per socket over 10 years. One consequence of that, as virtualization takes more and more hold, is the so-called east-west traffic in a network context. When one virtual machine, go back to the pattern picture that I talked about, that I showed earlier. It may be an application instance, and another instance of the virtual machine may be a database instance. If they're talking, that communication is essentially happening within perhaps even the same core, or it could be in the same multi-core chip environment. increasingly more and more of this is going to happen. But in today's way of defining network communication, one is forced to go from one virtual machine to a centralized switch and then come back into a virtual machine that is on the same multi-core chip. It's a very inefficient east-west traffic. As more and more of the virtualization takes hold, as more and more of the scale-out designs become prevalent, this becomes very complex, very expensive. The other is the aspect of multiple switches or heterogeneous switching environments. It is very difficult to manage them because they are in silos. To put it very simply, they are in very silos. So what the industry is working on is the ability to redefine how networking functions are delivered more as applications with a set of APIs for what the industry calls a software-defined networking platform. A set of capabilities for providing network control, data control, and taking into account virtualization and making that combination of open source based as well as standards APIs based. Let me explain a little bit about how that works. The two problems that I mentioned, the east-west communication in a virtualized networking environment and the complexity of managing multiple networks, these are being addressed with two different technologies or two different standards. The first one is called the Distributed Overlay Virtual Ethernet. In this, essentially, the separation of the virtual network from the physical network is achieved using standards-based interfaces. With that, as networking between virtual machines moves into the hypervisors, hypervisors gain the ability to configure and manage these networks and leave the physical networking intact. Because in today's world with virtualization, every time you reconfigure a network, you have to reconfigure the physical network. With distributed overlay virtual Ethernet, that need goes away, makes it more efficient. The second is a technology or an initiative called open flow. Open flow is a way of taking today's monolithic control plane and data plane based switches and breaking them up in management along with the network virtualization and virtualization management. This trend is happening very rapidly. This is not an IBM trend, I need to reinforce that. But IBM does get a lot of capabilities into this through the acquisition of the blade and networking technologies, which brings in many of these components and the capabilities here into IBM. So this is where the industry is going. But how does that intersect with what we discussed as the solution capability, flex systems, and pure AS systems? Now going back to my earlier picture that I mentioned, the connectivity for a workload where the components of the workload are interconnected and hosted in virtual machines and interconnected using a topology or a configuration pattern. Now that can be extended once this is virtualized, once the hypervisors are able to deal with this, and these patterns, the two kinds of patterns, system patterns that essentially allow network configurations, virtual network configurations, they can be part of the system patterns. And at the workload level, integrating the application patterns, the pure AS patterns, can be extended to include this so that the automation and the management capabilities of these can be extended across the entire stack. So this becomes a very synergistic trend in the future. So we have talked about our perspective on what smarter computing is, what is involved in doing it, and the fact that there is a portfolio that is needed. So I'm just going to illustrate with the help of a few client examples. In the design for data, not only do we continue to have enterprise content management, not only do we continue to have databases and a number of branded software to help that, but specifically we also have something that we acquired as entity analytics, but now we call identity analytics, that helps provide the disambiguation that Joseph mentioned about doing analytics on data in doubt. Especially in the context of fraud management, this becomes very, very important. So we have included that in that portfolio. Much more recently, we also introduced the ability to take the Netezza data warehousing platform, an appliance that I mentioned earlier, and connect that at the back end of a mainframe Db2. And what this allows you to do, what it allows our clients to do, is to use Db2 as a front end, which they're already dealing with, and extend the ability to create and manage an enterprise data warehouse which sits on the Netezza at the back end, but the management of the front end, including the workload balancing and the optimization of whether a simple query runs on Db2 on the mainframe and a complex query runs on the Netezza at the back end. These can be done and automated using Db2. And this is what we have called the IBM Data Analytics Accelerator, the IDAA, the Db2 Analytic Accelerator. And we have continued to have Cognos as the reporting analytics and predictive analytics on the basis of SPSS. In the Manage with the Cloud Technologies, I mentioned the fact that we've introduced Smart Cloud Entry, and Smart Cloud Entry is one of the integrated capabilities that I mentioned earlier, and the active cloud engine for storage, virtualization, and storage provisioning. You're going to see that. We have introduced that over the last 6 months or so. We are working with many production customers, and you're going to be able to see that in the Solution Cafe. In the Tune to the Task, we recently introduced V7000 with the smart tiering capability. We have talked about the pure systems, and Joseph talked about pure IBM Watson, so I won't necessarily go into it. But mention a couple of client examples. University of Maryland at the Baltimore Center, they used an IBM Blade Center along with the InfoStream and used parallel models for predicting wildfire direction and analysis, and that reduced the response time from hours to minutes so that you could actually act on it in near real time. China Ever-Growing Bank uses the Smart Cloud Engine to reduce their application serving capability, application provisioning deployment capability by 30%. And Fortuna is a Prague-based gambling company, uses V7000-based tuning or smart tiering capability to reduce the transaction response time by about 30%. There are many other examples all over the world that do the balancing between controlling the cost so that through workload optimized systems so that business innovation can be enabled. I'll give a couple of examples. I won't have the time for a lot more. One is GHY, which is a very small customs brokerage company in Canada. Very small staff. Most of the staff was stuck with doing hardware management for x86-based systems. By moving it to power-based systems, they were able to reduce the hardware management cost to such an extent they were able to create new capabilities like real-time tracking of customs. Axiom, many of you probably know, are a very large marketing services company. They were stuck with the problem of attracting new clients, retaining important clients, and they faced the issue of running out of their data center space. by doing the right matching between the workloads and their needs, they were able to increase their capacity with their existing data center about 5x, and were able to grow their business because they were able to deploy a cloud-based model for their marketing services. There are a couple of examples that I won't necessarily have the time to go through. I'm actually negative time. But I do want to close with one very important one, and that's the University of Pittsburgh Medical Center. Their intent was to try to create a smart patient room where everything was going to be electronic, including the electronic patient medical records and the diagnosis, including control accessing information to a smart, to a patient room, as well as the enforcement of the prescription. It was all going to be done with this. However, their concern was in order to implement that, they needed to build a new data center, which was going to cost them $80 million. By working with IBM and with the discipline that they put in place of matching the workloads to the right systems, they were not only able to avoid building a new data center, and they put that money into improving patient care, they now have enough headroom to live with their existing data center for another 6 years. So there are many, many examples of this. So the message is pretty much the same. One, you need discipline. Number two, you understand the future, and you need to get the right kind of IT infrastructure. So I'm going to close with this. There are a number of things that we in IBM bring to this, and part of that is the collaboration, and I hope we can continue to do the collaboration. Thank you very much.